Section 1.6 Design of an experiment. An experiment is a controlled study conducted to determine the effect varying one or more explanatory variables or factors has on a response variable. Any combination of the values of the factors is called a treatment. In an experiment, the experimental unit is a person, object, or some other well-defined item upon which a treatment is applied. We often refer to the experimental unit as a subject when he or she is a person. The goal in an experiment is to determine the effect various treatments have on a response variable. An experiment is usually used to compare two different treatments. To make determinations in an experiment, a control group is required. Now, a control group serves as a baseline treatment that can be used to compare it to other treatments. For example, a researcher may want to determine if students using an e-text do as well on exams as students using a physical book. In this case, the researcher could let the group using the physical book be the control group, since this has been around longer. A second method for defining a control group when medications are involved is through the use of a placebo. A placebo is an innocuous medicine, such as a sugar tablet, that looks, tastes, and smells like the experimental medication. Blinding refers to the non-disclosure of the treatment an experimental unit is receiving. A single-blind experiment is one in which the experimental unit or subject does not know which treatment he or she is receiving, but the researcher does know. A double-blind experiment is one in which neither the experimental unit nor the researcher in contact with the experimental unit knows which treatment or experimental unit is receiving. To design an experiment means to describe the overall plan in conducting the experiment. Steps in conducting an experiment. Step 1. Identify the problem to be solved. Should be explicit, should provide the experimenter direction, should identify the response variable and the population to be studied, often referred to as the claim. Now, step 2, determine the factors that affect the response variable. Once the factors are identified, it must be determined which factors are to be fixed at some predetermined level, the control, which factors will be manipulated, and which factors will be uncontrolled. Third, determine the number of experimental units. As a general rule, choose as many experimental units as time and money allow. Techniques exist for determining sample size, provided certain information is available. Step 4, determine the level of the predictor variables. Control. There are two ways to control the factors. A, set the level of a factor at one value throughout the experiment if you are not interested in its effect on the response variable. B, set the level of the factor at various levels if you are interested in effects on a response variable. The combinations of the levels of all varied factors constitute the treatments in the experiment. Randomize. Randomize the experimental units to various treatment groups so that the effects of the variables whose level cannot be controlled is minimized. The idea is that randomization averages out the effect of uncontrolled predictor variables. Step 5. Conduct the experiment. Replication occurs when each treatment is applied to more than one experimental unit. This helps to assure that the effect of the treatment is not due to some characteristic of a single experimental unit. It is recommended that each treatment group have the same number of experimental units. B. Collect the process of data by measuring the value of the response variable for each replication. Any difference in the value of the response variable is a result of differences in the level of the treatment. Step 6. Test the claim. This is the subject of inferential statistics. Inferential statistics, the process in which generalizations about a population are made on the basis of results obtained from a sample. Provide a statement regarding the level of confidence in the generalization. Methods of inferential statistics are presented later in this text. In the later chapters, we will run hypothesis tests, and we will get into all this information. A completely randomized design is one in which each experimental unit is randomly assigned to a treatment. So we could start out randomly assignment of 12 cars. So we're going to split the 12 cars into 3 groups, 4 cars, 4 cars, 4 cars. And then we're going to give 4 of the cars 87 octane, 4 of the cars 89, 4 of the cars 92 octane. And then we're going to compare the miles per gallon. This would be a randomization. Now, a matched pair design is an experimental design in which the experimental units are paired up. The pairs are matched up so that they have somehow related, that is, the same person before and after a treatment, twins, husband and wife, same geographical location, and so on. There are only 2 levels of treatment in the matched pairs design. A randomized block design is used when the experimental units are divided into homogeneous groups called blocks. Within each block, the experimental units are randomly assigned to treatments. So we could take 130 students, 60 men, 70 women. Block 1 would be the men, block 2 would be the women. And then we would take 30 of them to online section, 30 to a traditional section. Compare their scores for the men. Do the same thing for the women. Split them into 2 groups, 35 online, 35 traditional. Compare their test scores. And then in the end, we can compare the males to females. Okay, this is the end of section 1.6 and the end of chapter 1. At this point, you want to go through your notes and complete the section quizzes and the chapter quiz on my stat lab. Thank you.